Welcome to the deep dive. Today, we're tackling a really big logistical challenge. Think about major ticketing companies, sports leagues, anyone scheduling tons of events.
Yeah, events that change all the time.
Exactly. High volume and high change. We're using the NFL 2025 schedule as our model here.
Yeah.
32 teams, 17 games each, big numbers.
Mhm.
Our mission today is to sort of unpack the tech behind how the pros load, track, and instantly update potentially thousands of calendar invites. We want to see how they turn basic schedule info into something, well, dynamic and reliable.
Right. It's where scheduling gets serious meets real industrial tech. Because when you, the listener, look at that NFL schedule, you might see, what, 544 games?
Yeah, something like that.
But the system, the tech we're talking about, sees 544 potential points where something could go wrong. A time change, maybe a venue swap, could even be weather.
And that ruins the experience for the fan.
Right, totally. So the core idea we're digging into is how a specialized system, like, say, this AWS calendar invite server, using Calendar Snack, how it solves this. It gives every single event its own, like, digital fingerprint.
A fingerprint.
Yeah, makes it trackable, infinitely trackable, and crucially changeable, mutable.
Okay, let's get into this journey then. Step one seems almost too simple, but it's also maybe the cleverest bit for the organizer. You don't start by typing in 544 games by hand.
Oh, definitely not. No way. The source material we looked at shows they use pre-made ICO files. You can get these from schedule providers pretty easily.
Right, so for our example, let's say we just grab the Arizona Cardinals IAL file. That's got their 17 games for the season.
And getting that into your own calendar, Google, Outlook, whatever you use, it's straightforward. You download the file, it's usually an ICS format, and you just import it.
Okay, simple enough. But you mentioned a crucial step, the hack.
Yes, this is key. This is what separates, doing this properly versus creating chaos. You do not dump those 17 games, or worse, all 544, into your main personal or work calendar.
Ugh, I can see why. That would be an absolute mess. Imagine trying to find your actual meetings among hundreds of games.
Exactly. Calendar chaos. So the hack, the recommended step, is to create a brand new, totally separate calendar inside your Google or Outlook account.
Just for this data.
Just for this staging data. You might call it, I don't know, Cardinals 2025 or NFL staging, something clear.
Okay, so it's isolated.
Perfectly isolated. That new calendar is your clean source of truth. When you import the Cardinals' 17 games, they land there. It helps the organizer manage the scale visually. They can toggle it on or off without messing up their day-to-day view. It's like data risk management for your source.
That makes a lot of sense. Okay, so the clean data is staged in its own little sandbox calendar. How does it get to the main distribution server? This part seems almost anticlimactic.
It really does. It's surprisingly simple. You basically select those 17 events in your staging calendar, and you email them.
Just email them.
Yeah, to a specific command address.
Yeah.
In this setup, it's create@calendarsnack.com. That single email acts like a trigger.
A trigger for what?
It tells the server, okay, grab this data, process it, get it ready for mass distribution. It kicks off this whole industrial process behind the scenes.
Okay, wow. So a simple email starts a whole chain reaction. What's actually happening on the server side then? It gets that create command. Then what?
Yeah, this is where the complexity really ramps up immediately. The AWS Calendar Invite server, with Calendar Snack as its user interface, gets that command, and it does just like store the file. It takes the calendar invite completely apart.
Disassembles it.
Right. Every piece of data time, date, description, location, everything gets extracted, and then it's stored in a database.
And this is where that digital fingerprint comes in.
Exactly. This leads to the absolute most vital piece, the unique ID, or UID.
UID.
A UID is the backbone. The whole system relies on it. Think of it as the permanent unique identifier for that specific event. Let's say Cardinals versus Rams, October 12th. Once that game gets a UID,
It's locked in.
well, not locked, but tracked. The system can now track every single interaction related to that one specific game forever. That UID turns a static line on a schedule into a live tracked asset.
Wait, hang on. So I send one email from my Outlook, and suddenly this whole, heavy-duty cloud thing spins up to manage my Cardinal schedule. That feels intense. Unless we're talking serious scale, right? What's actually running this? You mentioned AWS components, Lambda, SQS, Dynamo, S3. Can you break that down simply? What are those things doing?
That's a really good question. And yeah, speak to the scale. We're not building this just for 17 games or even 544. This architecture, it's designed potentially for, 52 million calendar invites sent out over a year. It has to be robust.
52 million. Okay, yeah, that's industrial scale.
Right. So let's break down the stack functionally. Think of Lambda as the quick worker. It's serverless compute. It runs the code instantly when that email arrives or an update happens. No servers to manage. It just executes.
Okay, instant processing. What about Dynamo? DynamoDB.
DynamoDB is super important. That's the database. But it's not like your old school SQL database. It's NoSQL, built for incredible speed at massive scale. When you have millions of UIDs and maybe an update comes in, Dynamo can check if that event exists, find its details, like instantly.
So it handles the speed needed for checking those fingerprints, the UIDs, across millions of entries without slowing down. Got it.
Exactly. Latency is key.
Yeah.
And you've got SQS, Simple Queue Service.
Queue service, like lining things up.
Precisely. Imagine 10,000 fans hitting Add to Calendar at the same second after a big announcement. SQS is like the traffic cop. It lines up all those requests into an orderly queue, making sure the system processes them smoothly without getting overwhelmed. It ensures reliability under load.
Okay, the queue manager. And S3.
S3 is basically your massive, durable storage closet. All the detailed tracking data, every yes, no, maybe response from recipients, it gets archived there long-term. Tied to the UID, of course. Ready for detailed reports later.
So Calendar Snack, the app itself, is really just the user-friendly front door, the interface, sitting on top of this powerful, scalable AWS engine room.
That's a perfect way to put it. It simplifies the interaction for the organizer.
Okay, this is starting to make sense. So we have the data ingested, fingerprinted with the UID, managed by this robust AWS stack. Now, the payoff. How does this actually get used? How does the system push this out?
Right, the distribution. There are two main ways this gets used, especially in what you might call transactional marketing, where the event is the transaction, in a way.
Okay, use case one.
The first one is probably the most common you'll see, the embedded calendar, or sometimes called a one-click send. The system, via the app, pulls the upcoming events, maybe the next 3 home games for the Cardinals, and displays them right there on a web page.
Like on the team's website or a ticketing page?
Exactly. So a fan is looking at the schedule, they see the games, there's a little box for their email, they type it in, click one button.
And boom, the invite appears in their inbox or calendar app. Super simple.
Frictionless. That's the goal. Behind the scenes, that's usually powered by a specific API call, like a single calendar invite send API. It just delivers that one invite, perfectly formatted, right away.
Okay, nice and easy for the fan. What's the second use case?
That's more for the big blasts.
Yeah.
Bulk sending. This is where the organizer has their list. Maybe it's season ticket holders, maybe people who signed up for schedule updates. They upload that email list.
Could be thousands of emails.
Oh yeah, tens of thousands, potentially. The system then does a batch send. It pushes out those calendar invites, maybe the whole season schedule to everyone on that list in one go.
Okay, so single sends from a web page or massive bulk sends. But you mentioned tracking earlier. It's not just about sending, right? It's about knowing what happens after you send. How does that work?
This is where the UID becomes the hero again. The system isn't just throwing invites out there. It's built to request and collect detailed feedback, the calendar receipts.
The yes, no, maybe responses.
Exactly. The coveted RSVP data. It tries to collect that from every channel it sends through. This data flows back and gets shown in the organizer's dashboard in the Calendar Snack app.
So the organizer can see in near real time how many people are accepting the invites.
Yes, but it's even better than that. Because everything is tied to the UID, the data stored in S3 is incredibly granular. You don't just know engagement is up. You can see exactly how many people accepted the invite for the Cardinals versus Panthers game on December 1st.
Wow. So scheduling data becomes marketing intelligence.
Precisely. Actionable metrics tied to specific events.
Okay, that's powerful. But sports schedules, they change a lot sometimes. This brings us back to that core problem. Things are volatile. What happens if the organizer needs to change something after they've sent it out? Let's use that example. Cardinals versus Saints. The organizer needs to shift the start time from 11:00 a.m. to 11:00 a.m. And maybe they want to add a promo, like free hot dog if you arrive early.
Right. A logistical change plus a marketing update. How do you push that out reliably to potentially thousands of people who already have the old details in their calendar?
Yeah, how do you do that without causing mass confusion?
The beauty of this architecture is the organizer's action is still simple. They don't need to draft a correction email or anything like that. They just go back to their original staging calendar, that Cardinals 2025 one we talked about.
The source of truth.
The single source of truth. They find the Saints game event, change the time to 11:05, edit the description to add the free hot dog bit, and just save it.
That's it. No rescind button, no code.
Nope. That's the magic.
Yeah.
The AWS backend, the server architecture, it's designed to constantly monitor that staging calendar. It uses something called a Lambda listener.
A listener.
Yeah, think of it as a dedicated function that's periodically checking or polling the organizer's source calendar. Anything changed. Anything changed.
Okay, so the listener wakes up, sees the Saints' game details are different in the source calendar. What then? How does it know who needs the update?
The UID, it sees the changes linked to, say, UID 67890. It then instantly checks its database, that fast DynamoDB, for every single recipient who originally received UID 67890.
Ah, so it has a list of everyone who got that specific invite.
Exactly. And the system is smart enough to figure out, okay, this is an update, not a new event. It automatically generates and sends out a new calendar invite file with the updated time and the hot dog promo. This new invite has the same UID, so for the end user's calendar, like Google or Outlook, it just seamlessly replaces the old details.
Automatically, without the organizer doing anything other than saving the change in their source calendar.
Completely automatically. And this isn't a one-time thing. They could change it again half an hour later if needed. Unlimited updates, all triggered by simply editing the event in the staging calendar. It's an iterative process.
So that last-minute hot dog promotion gets delivered with the same reliability as a critical time change. That really underscores how it treats these as transactional communications. What about people who, never responded? Did they get the update too?
Good question. The system tracks responses. If someone responded yes or maybe to the original invite, they definitely get the update. You want to keep engaged people informed. If they never responded or maybe even deleted it, the system knows they received the original UID, but it might not automatically send the update unless it's flagged as critical, like a cancellation. It focuses the updates on those actively using the invite.
Okay, that avoids annoying people who ignored it initially. What if the game is completely canceled? Organizer just deletes the event from the staging calendar.
Yep. They just hit delete on that event in their Google or Outlook staging calendar.
And the listener.
The Lambda listener detects the deletion. The system recognizes, okay, UID 67890 is gone. It interprets this as a cancel command. It then automatically sends out a formal cancellation invite.
Not just an email saying it's cancel.
No, a proper structured calendar cancellation. It goes out automatically to everyone who had previously responded yes or maybe. This actually removes the event cleanly from their personal calendars. It's an automated retraction.
Wow, okay. The big takeaway here seems to be that single source of truth. The organizer lives in one clean, managed space, their staging calendar, and every single change, big or small, update or cancellation, just flows downstream automatically and instantly.
That's the core principle. Reliability through automation, triggered from one simple, controlled source.
So tying this all together, this backend you described, Lambda, SQS, Dynamo, it sounds like it's built for some serious heavy lifting.
Absolutely. If you connect it to the bigger picture, this infrastructure is designed purely for scale and reliability. Remember that figure we mentioned, potentially 52 million invites a year? The deep dive analysis on the cost for running that volume on AWS shows this isn't, a small business tool. It's industrial strength.
Built for the big leagues, literally.
Pretty much.
Yeah.
Which confirms where you'd primarily see this.
Yeah.
Transactional marketing, where the schedule is the product, like sports or concerts. And also for those embedded web calendar invites on websites, anywhere event details change often and accuracy is critical. Ticketing platforms, event venues.
It really shifts the idea of a schedule from just like a static PDF you download once.
Right. It transforms it into a live, real-time, responsive communication channel. And it lives right inside the tool people use to organize their lives, their calendar.
Okay, so let's recap this journey. We started with what seemed like a simple trick, using a separate calendar for a downloaded Execl file.
The organizer's hack.
Right, but that simple step, plus emailing it to a command address like create@calendarsnack.com, that kicks off a really sophisticated process.
Involving that whole AWS stack, assigning a unique ID, that digital fingerprint.
Which creates this automated analytical engine. It can handle potentially millions of invites and updates, making sure that if, say, the Cardinals game time changes or they add a promo or even cancel it.
Everyone who needs to know gets that update.
Yeah.
Instantly, automatically, reliably.
So the final thought for you, the listener, to maybe chew on?
Yeah, it's this. Think about how your own organization handles scheduling, even for internal meetings or project deadlines. Are you seeing those calendar entries as just static, one-off data points, forgotten once they're sent?
Or could you view them differently?
Could you see them as potentially tracked, quantifiable, changeable assets? This whole system demonstrates that it's possible. It turns basic scheduling logistics into a potentially powerful, measurable communication strategy. How might that change how you think about your own scheduling?
Something to definitely mull over. Thanks for diving deep with us today.